Oh, what up, everybody? That was weird. Tried to go live, and it was like, live streaming's not available right now. And then it was like, congratulations, you're live. Whatever. Ah, sorry. Stuff's all wonk. All right, cool deal. All right, so yeah, I'm just gonna pick up where I left off last time, which was exactly jazz. I can't remember where it was. Oh snap! Sam's streaming too. Sam, yeah, she's like my mentor, one of the mentors I have. I see her that way. She's doing Unreal. I don't do Unreal, Sam. Sorry, not with Epic, not with it. But yeah, if you guys want to follow somebody that actually, is actually skilled in development, I'd follow Sam Yam. Guess I'll give her a little shout out. This is her page. Bam. Go over there, follow him, find him, check him out. They're good people. But yeah, now I will be following Code Monkey. Y'all got the link on the description or over in Twitter. I posted it up, so feel free to go in there, jump along, go at your own pace, follow with me. It's up to you. I'm doing these more again for just recording a vlog showing that it's tough being a game developer. You gotta go through this. If you don't know something, you gotta go practice. You gotta find that knowledge. You gotta absorb it. So this is what I'm doing. Decided to go live with it just so people can get a taste if they jump in and be like, hey, how you doing this? Or hey, you're doing that wrong. Because God knows I'm doing a lot wrong. But yeah, just hang out or not. It's up to you. But yeah, let's get it. I didn't finish eating, by the way. I'm so hungry. It'll be all right. We got this, right? Yeah, good. All right, let's go. Let's see. Oh, I figured that out. Create, do object, place it. You say it with time. Yeah, okay, I remember. So here popped open grid building system. Where's our grid building system? Bam. You know what? Y'all forgive me. I'm going to mute while I do this because I'm going to be eating while I'm doing this. So yeah. Hang tight, y'all.
So when to set the transform and when to clear it, which we're going to use later when we implement demolish. And let's also modify the toString to also include what transform is on there. So just make a new line and then the transform. And also the way that the debug visual is set up, the grid class needs to know when something changes. So just here, just trigger a grid object change, passing this one and this one. Just so that the grid knows when something changes and then it updates the text. Okay, so we have our transform, and now let's make a simple function to test if we can build. So just a public returns a boolean, let's call it can build. And here it's very simple, we just return if the transform is null. So if transform is null, then we can build. If it is not null, then we cannot build. Okay, so now here on our update, we get the grid position. All right, now before we instantiate, let's go into the grid and we get the grid object on this X and this Z. So this returns our grid object. And now here we go into the grid object and we ask if we can build. And if so, then we are going to build it. And after we instantiate, let's do a build transform to grab our reference. Then we go into the grid object and we set the transform to this one. So we build and we set it, and if not, then that means that we cannot build. So for this, let's spawn a fun pop-up message. So here I'm using this function from the utilities, which you can grab for free from unitedcodingmonkey.com, or of course you can make your own warning message, like for example the tooltip that I covered previously. Just a bit of fun, just telling the player why it cannot build. Okay, so with this, let's test. Okay, so here I am, and if I click, yep, there you go, it gets placed, and over there on the text we can indeed see that it worked. So we can see that this grid position is now filled with a building clone, alright. And now if I click again, nope, there you go, now I see the nice pop-up saying that I cannot build because that one is already occupied. Alright, awesome. So with this, we already have a really good start. We can place down buildings anywhere you want, and we make sure that we only place them on clear ground. So this is working, but so far it's only working with this shape. However, in most games, when you have a building system, you don't usually have just a single one-by-one shape. Some things you want to place will occupy more than one grid position. So let's handle that. And by the way, if you find the video helpful, consider subscribing and hitting the like button. It really helps out the channel. For that, the first thing that you need is some way of defining each building type. And for that, over here, I've got some building type scriptable objects. I covered scriptable objects in detail in another video, so go watch that if you're not familiar with them. Essentially, they are a great way to make some objects to store some data.
All right, yeah, so looking at the video, I'm noticing he has his prefab visual, then he actually has the visual of the object, so a little interested by that, but let's take a look here. So my prefab is this. Let's see. Oh, let me do that. How is he getting that info? Like, I'm wondering if the visual itself. Probably take a deeper dive into that, but I wonder if he's like dragging. What is he dragging over there? I mean, both are visuals. I'm just a little. We'll see. We'll see what happens. But what is. We'll keep going.
And also, this is the same method that I used to define the building types in my Complete Builder Defender course. So
Which
this
I have,
is an excellent
which I
way
should
to define
do.
various types. Here is the script with the definition. As you can see, it's pretty simple, just a handful of fields. Over here we have a name, a transform for the final prefab, a transform for just the visual, then an integer for the width, and another one for the height. Now here we're working on the XZ plane, so really the height is really more of the length, but personally I prefer the word height. Then the other thing we have is also some functions related to direction. We're going to see those in a bit. So essentially we have the scriptable object where we can store our name and our prefab and width and the height. And here in the editor we've got all various scriptable objects. Again, go watch that other video if you're not familiar with this. So we have multiple building types, and some of them, like for example the town hall, occupies more than one grid position. Here it uses a width and height of 2 by 2. So let's test our current code using this. First, let's refactor our code to work with the scriptable object instead of a transform directly. So here for the serialized field, let's make it of type placed object type scriptable object. And then type placed object type scriptable object. And then down here for transform, just go inside that and instantiate the prefab. Okay, so that's it, that's all it takes. Now in the editor, let's select the object, and over here let's drag the town hall reference. Okay, let's test. Okay, so here I am, and if I place it in here, and yep, so far so good, it worked perfectly. And if I try to place on this position again, nope, I cannot build. However, right away on looking at the text, you can see the issue that we have. So you can see that only this value on this grid position was set. So this one on 3.2 is not being occupied by anything. Same thing for that one and that one. So if I go ahead and click on this one, yep, there you go. Now they are.
Ah, okay. So let's see. Let's compile this up and see what's up. Oh, I missed that. Let's go ahead and put that out. See what's up. The problem is this isn't really set to a 2 by 2. Like if I were to do this right now. Oh, no reference. All right, let's just throw it in there. Oh. I'm sorry, what? Oh, yeah. Okay, so let's do it like that. Takes that. Puts it in there. Play. Well, it is using that, but the problem is right now I have it set to like not be 2 by 2, so let's choose a different model for that. So let's get rid of that. So it's still 1 by 1, right? Let's create a we'll call it, what do you name his, just out of curiosity? Building types. So he has this separated into something different. Let me try that. So he says These are housing house types, right? We'll take that. We'll put it here. Now he renames these. Just a simple matter of doing that. Interesting. Large house. Need this guy. Oh, because the string name. Oh, maybe not. Small house. House 2. Large house. Small house. All right, so for our large house, let's figure this out, shall we? We'll go with this one. Oh, that one's a little long. Per unit is 100. You know what? Better idea. Let's come over here. Let's take this. Oh boy. Better idea. Is that house 4? Let's take house 4, put it over here. Alright, cool. So we're taking a look at this. House 4 is that big. Let's house 4 needs to be bigger than that. So let's scale it up by 2. Let's see. How should we scale this? Perfect. All right, cool deal. Actually does exactly what we wanted. All right, so house 4 is now quite large. So if I come over here, take house 4, I put it there. I'm a little confused by like what he means by the visual. Like, how do you have only the visual? You have a prefab and you have a town visual. I'll have to figure that out later, huh? All right, let's go. Oh, wait. All right, let's see. I didn't put it in the builder. All right, cool. Let's go. But you can't place on top of each other. Ha. Aha. That's dope. All right. That's cool when it puts it in the center like we want it to. Man, that's amazing. I love this. I love it. I love learning like this. All right. So let's see. Yeah, I guess that works. I'm still a little confused. I wish I can get in touch with him, ask him a few questions, but he's a busy man. Code Monkey, you busy dude. I'm glad. I'm real happy for him, man. I was there back when he first was getting on and like doing Unity tutorials and stuff, and now he's like doing a live stream with him, like Unity itself. Bruh. It's always good to see people rise up with lots of hard work. All right, let's keep going.
Occupies more than one grid position. Here it uses a width and height of 2 by 2. So let's test our current code using this. First, let's refactor our code to work with the scriptable object instead of a transform directly. So here for the serialized field.
So we did
okay,
that.
So that's it. That's all. Okay, let's test. And if I try to place on this position again, nope, I cannot build. However, right away on looking at the text, you can see the issue that we have. So you can see that only this value on this grid position was set. So this one on 3.2 is not being occupied by anything. Same thing for that one and that one. So if I go ahead and click on this one, yep, there you go. Now they are overlapping. So this is the issue that we want to solve. For that, essentially, we're going to need to fill in multiple positions on the grid with the same reference. Over here, we instantiate our prefab, all right. Then we go into the grid object and set the transform. However, we also need to know what other grid positions will this building occupy. So when working with the building with the size of 2.2, if I click here on 2.1, I want to occupy 2.1, 3.1, 2.2, and 3.2. So what that really means is we start on the origin position, then we're going to fill everything alongside the width, and also everything alongside the height. And here on the scriptable object, I've got a function to do exactly that. Again, for now, we ignore the references to the direction. All that matters is really just this. So this function takes an offset, so that's the base offset, like for example the position where we're clicking on, and then simply cycles through the whole width, cycles through the whole height, and then adds it to the list. So just the offset plus the x and the y. It just does that and then returns a list of vector2 ints. Now we can go back into the grid building system.
I mean, I have that because I downloaded I pulled the file down because before he didn't show any of that. He just showed the blank script and it was all collapsed. So I went in and grabbed it. Yeah, it's like he's saying, you know, case down, case up, do this, case left, nothing, case right, do this. Okay. Legit.
And here let's call in that function. So we're going to go into the placed object type scriptable object and call in that function to get the grid position list. And now we need to pass in the offset, which is going to be our...
I think someone's trying to knock in. Be right back. Not. Oh, somebody's knocking. I guess it's next door. Anyways, let's keep going. Where were
our xz, and this requires a vector2 int, so let's pass in the x and the z. And then for direction, again, right now we're not worrying about it, so let's use the default direction, which is down. We're going to see direction in a bit. All right.
so come up in here, placed object type. So we're gonna get our position list, new vector to int xy because we're not in 3D. So in the video, he does a lot of XZ because 3D. Since we're doing it in 2D plane, XY. Direction down. Blam. All right.
So this returns a list of vector2 ints. So this is the grid position list. So all of the grid positions that this building will occupy. And all we need to do is over here when we set grid positions that this building will occupy. And all we need to do is over here when we set the transform, instead of setting just on one grid object, let's cycle through all of those. So for each vector2 int, for each grid position in the grid position list, for each of those, we're going to go into the grid and get the grid object on this grid position. And then we do our set transform. All right, so now we are set.
Damn. All right. So this is a list. be a list of vector2 ints. Call it grid position list equals that. Then he comes down. And here he puts us in a for each loop. So I guess he goes through there. Grid position. Grid position. Oops. In grid position list. Do the following. I'm guessing that gets kicked out eventually. Grid dot get grid object grid position dot x grid position dot y set transform built transform from there.
Setting the transform on all of those, so let's see. Okay, so here I am, and as I click, yep, there you go. Now it does fill in all the positions. So if I click here, nope, can't, nope, nope, and nope. All right, great. So placing is working. I cannot place any more on any of these positions. However, we still have one issue. If I click...
Now let's see if that works for us. So he was about to say
over
something.
Here on the left side, and I click, and yep, there you go. Now we've got another overlap.
You can still
So the
click
issue is that right now we're only testing if we can build on the clickable position. The answer is we need to apply the exact same logic that we just saw. We need to test if we can build, not just on where we click, but on all the positions that will be occupied by the new building.
Yeah.
So over here we got the...
All right, so place it. Bam. Actually, I can't place it there. I have to place it somewhere else. It's interesting though. I need to fix this. It's supposed to, if I'm outside the bounds or if I'm in an illegal position, it's supposed to handle that gracefully. Instead, it just kind of goes, and freaks out. Yeah, I figured that out. Let's see. Okay, so put it there. Oh, it's still wigging out on me. It's not supposed to do that. Okay. All right, so what didn't happen that was supposed to happen? Grid object can build. Ready down for each grid position in grid position list. Click it. Position list. 2 XY down. And huh. Set transform. Built transform. Instantiate the prefab. Get XY. Yeah. Aye. Alright, let's see if it works now. Okay. Yeah. Now, all right, cool. That works, right? I need to see if it actually puts a thing up on each square that he has. Let's take a look. It does. Okay. Cool. So this is how it's supposed to turn out. And the reason it did that is because in the scriptable object I created, I forgot to actually list out the width and height. It was 0. So it was just like, okay, I built it, but I mean, it's only here. The problem we ran into following that is you can still do this. Well, you can't build on the squares. You can build into it like that. And that's no bueno. Okay, so let's get tackling that one.
Grid position list, we just need to call can build on every single one of those.
Oh, wow. He's just throwing it in there real quick. Testing can build.
All right, so here's the logic. So we just go through every grid position on the grid position list, all right? And then we test for every single one of them if we can build. And if there's just a single one that we cannot build, then we set this can build boolean into false. We break out of the cycle, and then down here, either it passed all of them or it didn't pass at least one of them. So if we...
Okay. Kind of seems like a way, but you know, you got to build it rough first if you're going to build it smooth later. So let's see. So this is just our test can build. So what he does is he says boolean can build equals true for each vector 2 int grid position. Yeah. If grid dot gets grid object position dot x grid position I mucked that up. Case matters. Hi. What? Whatever. Dot can build. And can't build here. Don't build here. And build false. Then he puts this whole thing. Well, wait a second. What does he do with the grid object? Oh, hold up. What?
we test. So over here, either it passed all of them or it didn't pass at least one of them. So
Yo, where does this go? I just realized this whole thing just fucking disappears. that's weird. All right, let's see some. Kind of need that. Yeah. He comes up in here and he just. So it looks like, I guess he does this to like check it, right? So if can build.
So if we test, so over here, let's build in here. All right. And if I click here, 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 or here, nope. All right. Everything works. And now if I click here, and nope, cannot do it. If I click here, can't do it, can't do it, and can't do it. But if I go here and click, yep, now it does work. All right. Awesome. So we now have the ability to place down buildings with different sizes. Now next, let's handle rotation. For that, let's test with the gas station, which has a width of 2 and height of 1. So here, if I place the gas station, yep, there you go, it's like that.
That's dope.
So let's rotate this one. As we saw previously on the scriptable object, I already defined an enum for the direction. So just
I should have just watched this. Damn, he does. Eli goes through and explains it. Somebody came in here one time and told me, just watch the whole thing first, homie. I should have listened to him. Yeah, all right. I'll listen.
Left, up, and right. Now in the grid building system, let's store the current direction. So let's go into the placed object type and store a direction. So the current direction that we want to build. And let's default it to down. All right. Now for the rotation, we need to swap this. So let's go into our update. And in here, let's...
Oh, hold up, bro. You left me. Placed object direction.
Now for the rotation, we need to swap this. So let's go into our update. And in here, let's listen, let's say input get key down. When we press the R key, then we want to rotate the direction. So over here on the scriptable object, I've got this function to swap out and get the next direction. So down goes into left, left into up, and so on. So here we just get the direction, go into that function, and pass in the current direction.
Yo, that's pretty cool. If input down key code or rotate, you take the direction. Direction is going to equal the function in placed object type scriptable object get next direction. We're going to pass in that the dir from here. Code.r, bruh. All right, cool.
Okay, so now we've got a direction that should always be swapping. Let's do a quick test. So just print out the direction. Let's see. By default, it should be on down. So if I press the R, it should say left. Yep, left. And then go into up, then to right. Then
he did something else. That was too transfixed.
So just print out the direction. All
right, cool. And then utility class, create world text pop-up, cluster, mouse 3D, dot get mouse world position. I'm dumb. I'm copying to verbatim. We're doing it in 2D, folks. 2D.
Let's see. By default, it should be on down. So if I press the R, it should say left. Yep, left. And then go into up, then to right, then down, and so on. All right, everything works. Now, as we saw on these functions on the building object type, it already takes a direction. So here, instead of putting in the default one, let's choose the one that...
Hey, can't tell you these little things, man. That's so dope. Fucking love it. Is it really gonna rotate? Oh, it doesn't rotate it. Damn. Okay. Oh, you know what? That's probably why it needs the visual. I need to fix that. Hmm. All right. All right. Let's see. See, because it's, yeah, hold up. All right. So we see that, right? Let's go in here and try to work with this because this is actually, so I'm going to, should be left. Oh, there. All right. Let's try to find that, this object. So what? It's now rotated. Something in here has to rotate. It's not actually rotating. All right, let's see. Your rotation angle. I need to figure this out. If I rotate this, what? Oh! Out of existence. So the Z has to change. Get grid list. My direction shifts. I guess. Let's see. All right, let's see if that does anything. Probably won't. Let me see. Hold up. So I went in here. What I did, got a list the grid positions, right? What this does is it messes with the offset. So grid position list add offset plus new vector position. And I just changed it. That's not gonna change anything. Whatever I name it, that's not gonna change anything. I need to change it over here. Let's mess around with something real quick. Put that down. Yeah, it's not gonna change it. So the area ain't gonna change. It's supposed to be this. Yeah. So my Z on my sprite needs to change. Although technically it looks a little funky if you change a 2D image like that, because then it's not exactly rotating correctly. But you know, I get the rotation thing. I just need to implement it. That way I can actually say I understand it. Because as of right now, shit, I don't know what's going on. Let's see. And I was dumb for thinking this was gonna change something. That has no real bearing. All right. Wonder when it calls this. Get rotation angle. Get next rotation. Okay. And then I need it to do get rotational angle. Grid object. I think it wants the visual, that way it can go in there and change the visual. to rotate. Let me keep watching.
That we're currently using. Let's see how this function is set up. So here on the grid position list, as you can see, the only difference is swapping the width and height for height and width. So on the down and up, we've got some horizontal values, and on left and right, we've got some vertical values. Then we've got the grid position list, so all very simple. Just like this, we should already be filling in the correct grid positions. Let's see. Alright, so by default, we have direction down, so if I click here, it should occupy this one and this one. Click, and yep, it did work, alright. Now I press the R, now I'm looking left. So now if I click here, it should occupy this one and this one. Let's see, click, and yep, it did work. Now I press again, now it's pointing up, so it should place here and here. So click, yep, it did work. Now
That's right. That's right. So technically, all right, so what he's doing is good thing. I know y'all hit me up. You just said you'd watch the whole thing. Yeah, I know it. Let's get it. We have to create another long house here. Let's see. So we go in here, we create long house, right? Long house. And what we're gonna have? We're gonna take it's not a house, that's a well. Whatever. We got him being big house, right? Hey, big boy. We're gonna do what we gonna do for a long house. Let's take this. That one. Wait, we already have house number 2. Small house. We'll take house number 3. Whatever. So we'll take house number 3. We're gonna turn him into a long house. How about house number 5? Oh, jeez, didn't mean to do that. So, bruh. Oh, I'm stupid. I will take house number 5. We'll turn him into a long house. Oh, wrong way. The White House. That door is massive. Actually, you know, can we do a little magic here? Let's try a little magic here. All right, so we're gonna take 5, right? Let's not. We'll keep it simple. We'll do it like that. We got ourselves a wide house. So the long house is gonna be house number 5? Yeah. So prefab 5. Bam. All right. So you come back over here just to see it. Oh, geez. Okay, hold on. So we come in here. I'm gonna take the long house, slap him in there, hit play. Oh no. Oh. You gotta remind me of that. Alright, so put him down. Can't build. Then we're gonna rotate it so it should be facing left. So if it's facing left, if I rotate left, it should be like up and down now, right? So nope. Yeah. Yeah, it's still doing what we thought it'd be doing. All right, so we need to figure that out because he got it working.
So now click, and yep, it did work. All right. Now I press the R. Now I'm looking left. So now if I click here, it should occupy this one and this one. Let's see, click, and yep, it did work. Now I press again, now it's pointing up, so it should place here.
That has to do with the rotations though. Alright. Let's do a little bit of this. The prefab get that when he hits R, the direction should switch left. That ain't happening for me.
Here and here, so click, yep,
watching.
it did work. Now again for the right, it should place, if I click here, here, and here, so click, and yep, it did work. All right, so all the grid positions are all correctly being rotated. Now let's actually rotate the visual. Over here on the scriptable object, there's another function to get the rotation angle of a certain direction. So if it's down, it's rotated by 0. If it's to the left, by 90, 180, 270. All right. So let's use this and apply it to the instantiated prefab. Over here on the grid building system, when we instantiate it, we're calling instantiate, passing in this prefab, then we pass in this grid form position, and then the quaternion identity. This is what we need to change. Let's go into quaternion, and we're going to create a new Euler angle, and we're working in 3D. So we just want rotation on the y-axis, so 0 on the x. Then for the y, let's go into the placed object type, and we get the rotation angle. Pass in the current direction, okay, and then on the z, also 0 rotation. Okay, so like this, it should be rotated. So,
see, that's where I'm having problems, right? Because the visual should be updated. So what he's showing is he goes in there and he gets this, right? Right now, he's only operating on this, this, and this. Which I guess also operates off of this guy. So even when he does put this down, like that, it should be rotating it up and down. If I come in here and I look at this, I should add something that makes me that shows the direction. Like if you were to come over here, hit R, it's facing left, right, left, correct? It should be showing these two, but instead it's still only showing those two.
So first, the default rotation, click, yep, it works. Now press the R, and I'm going to click here, and yep, it did work. It did rotate 90 degrees. So it worked, but you can obviously see the issue. We're rotating around the transform pivot, which is right here on the corner. So as we rotate 90 degrees, yep, it occupies down here. So after we rotate, we essentially need to offset it by a certain amount. So in this case, we need to offset by the width over here on the Z axis.
See, the problem is I'm not getting that. I need it to rotate. Okay. Skip ahead to where he says you can do it in 2D.
So there you go. I can place any of them anywhere. And yep, all the logic still works. So if I place this in there, nope, cannot build, place in there, and it does work. So as you can see, it's very simple to make this same system work exactly in 2D. You can download the project files and see how the class works for yourself. Alright, so there you have it.
Interesting. Well, I don't know how often I'll actually have to rotate something on a 2D plane. So, but we'll give it a shot still. We'll see. We'll see what we can do. How long we've been going? An hour. Not bad. Probably be dipping out here soon. Walk ye old dogs and all that. Why? Bruh. Okay. All right. Let's look. Let's take a peek up in here. All right. So none of this is gonna work. I don't think I have the stuff downloaded to actually make his project file work as soon as I bring it up. Yeah, nope. That's all right. Anyways, 2D render. I don't know how to get this thing up and running. Universal render pipeline. All right. Well, we'll just leave that as. Let's see. Nah, fuck am I thinking? Probably. Would be surprised. So you got the mouse position. X, Z. Okay. Guess he just calls it that. Can build, get the rotation offset, place object, get the offset direction, place objects, get world position, X, Z, plus your new vector, your offset rotation, X and Y times the cell size. All right. Placed object done. Place object. No. It's another script he's got, isn't it? Yeah, he made a whole another script to check that. So, public static, place object, done, create, world position, origin, transform, placed object, transform, object equals get component, place object done. So it's looking for that. Place object dot setup, place object origin, return placed object. Then sets the classes for this. So set your origin. So your setup, your origin, your direction. Place object, origin, direction. And grid position list returns the list. Stores itself, override string. I mean, I understand this. Put key down. No. Oh, that switches the types. Okay, cool. Get mouse 02. Or, shit. Deselect. Huh. Get placed object rotation. In what scenario would we rotate a not top down, but a 2D item? Because I mean, technically, we're looking at this. That same one, this one. So you're looking at it, right? Say you're building a village or something, right? You're gonna place an object. You're never really gonna place it and then have it be like upside down. That just doesn't make any sense. I mean, I guess you could. That's more of like an art thing. Like somebody blew over a house or something. But nah, I think that's I think we may be looking to do something just for the sake of doing it. I kind of feel like that's a waste of time, but at the same time, I feel like I need to learn that. So let's go in here and give this a shot. we ended up coming in here. Got the X and Y. So he spits out Z is the origin. Let me go ahead and finish watching this, and then I'll come back.
Also Z rotation. Okay, so like this, it should be rotated. So first, the default rotation, click. Yep, it works. Now press the R, and I'm going to click here. And yep, it did work. It did rotate 90 degrees. So it worked, but you can obviously see the issue. We're rotating around the transform pivot, which is right here on the corner. So as we rotate 90 degrees, yep, it occupies down here. So after we rotate, we essentially need to offset it by a certain amount. So in this case, we need to offset by the width over here on the Z axis. So here is another function on the script logic to do just that. It calculates the rotation offset of a certain direction. So if it's pointing down, there's no offset, so it gets placed exactly where it is. If we rotate to the left, then it gets offset on the Y, which is really the Z, by as much as the width, and same thing for the up and right. So here we just need to apply that over here to the spawn position. Okay, so here it is. We go into the scriptable object, we get the rotation offset for the current direction, and we get a vector2 int. Then we calculate the final placed object worm position, so we get the grid worm position, so the same one that we've been using previously. And then we simply apply our offset to it. So the offset is on the X and on the Z, and we just multiply that offset by the grid cell size. So now everything should be correct. So here, first of all, place down, click here. Yep, it worked. Now press the R. So now on the left, now if I place here, yep, correct. Place again, up, let's place here. Yep, now it's pointing up. Place again, now for the right, click here, and yep, it is pointing to the right. Alright, so we've got all 4 of our rotations. Now let's just add some logic to swap the building type. So for that, we can just go up here, instead of exposing the placed object tab, let's expose the array of it. So here I'm exposing a list, and then let's hide the private one, so it's the selected one in all of them. Then on awake, let's default it to the first one on the list. And then here, just listening to some alpha inputs and swapping this one out for a different one on the list. Now finally, just need to populate that array. Okay, let's test. Now by default, we should be placing the building. Yep, there it is. Now I press the 2 key. Now I place a fire station, press the 3, and now a gas station, and now that one. On 5 that one, and on 6, yep, I've got a mansion. And now I can rotate it, and there you go, it rotates everything, and everything is indeed working correctly. Alright, so we can already build anywhere. Now let's handle our demolish. So this is pretty simple, but requires a bit more data. For example, let's say I want to demolish this mansion. And I put my mouse here, and I do a demolish. So this grid position contains a reference to the transform, so I can easily destroy it. But then let's think of what happens with the grid position. I can clear this one since I click directly on it, but right now I don't know what other position should also be cleared. So that means that we need to keep track of what positions each building is occupying. So in order to handle that, let's refactor our code to work with a proper class instead of just a simple transform. So let's make a new script. For this one, let's name it the placed object. And we're going to attach it.
Okay. So that seems to be a universal one.
This script onto all of our objects. So for example, this is why I separated the prefabs from the visuals. So the visuals just have the visuals, whereas the prefabs have the visuals and any other logic that you want to add.
Oh, man. Oh, I keep kicking myself for saying not watching the whole thing through. It's okay. Dang. Dang. Oh my goodness, bruh. Alright, let's do it. So create a folder in here and call visuals. We're gonna take these, we'll copy them. Paste them in there.
Have the visuals, whereas the prefabs have the visuals and any other logic that you want to add. So
I need to work on my naming convention and stuff if that's the case too. So we can do prefab 1. We come over here, we're gonna name it prefab 2. You come over here, you come over to large house. Large house is number 4, so you take your prefab, put them in there, and then you take your regular. That way you're not mucking it up. I see, I got you.
have the visuals, whereas the prefabs have the visuals and any other logic that you want to add. So this is always a great way to do things. Now in this script, let's store all the data that we need for this building object. So essentially the data that we're going to need is going to be the object type, then we're also going to need the origin and the direction. Okay, so these are all the fields that we need. Now we're going to need to receive this data. So on the grid building system over here, we are instantiating our build transform. And instead of doing it in here, let's make a function on the placed object that is responsible to create it, and we pass in all of the data that we need. Alright, so here...
Damn, he just busted all that out. Love to know how he just knows this stuff, man. Like, I can understand going to the API and reading it, but it's like, do you read through the whole API and then somehow go, this is what I'm looking for? I wish I could talk to y'all about Thomas Brush, because like I paid for his course back a while ago, right? And he talks about a lot of this stuff, and he talks about a lot of just like, you're a game developer, you're not a programmer. If you are a programmer, kudos, you got a huge advantage. But if you're a game developer, you don't have to know all the intricacies of the language. When it comes to the API, it's a lot of learning on the spot. Like, I don't know how he came up with this. I don't know how he was just like, yo, I need these things, right? Like, I need this, I need this, I need this. Like, oh, I know I need to do a vector 3, vector 2 int. I know I need to get this. Like, You won't know that. Like, you're not gonna know that off the bat. You're gonna be bumbling around. You're gonna make something busted. It's just like, say, for instance, you make a game, like a menu system entirely out of if else conditions. Like, you can do that, but it's not gonna be like, you'll find out quickly that there are better ways to do it. And that's just a thing that you gotta bust your ass first, and then afterwards you're like, I could do that much better. But anyways, I digress. I always get fascinated when I like follow these people I watch, or like my mentors do stuff, and I'm just like, how the heck did you figure that out? Like, what were you doing? You just sitting there? Oh man, I built it the first time, and then I realized there's a better way to do this, or there's got to be a better way to do this. So yeah, it's just how it is, apparently. Public static placed object create vector 3 world position vector to int origin placed object type dot dir placed object type so placed object so dang, I don't know how that thing cuts off the screen. I gotta pull up his other one. I wonder what the difference is between. I don't think there's a difference. So he just has that. Okay. And yeah, I know. Sometimes I'll type it out. Sometimes I'll copy paste it. But for this, I'm trying to just. This is just how I work, man. No, there's no real difference to y'all, but it is for me. Is it rotation angle or rotation offset?
I made this nice static function. It returns a placed object, and we've got the create. We receive an input for the world position, then for the origin, another one for the direction, and then for the building type that we want.
So it's the angle, rotation angle.
Place. Then we simply do instantiate, the exact same thing that we saw previously. And then we simply do a get component in order to get the placed object component, and we fill in all the data. And finally, we return it. So now this class is responsible for creating the transform and holds all the data related to the building. So now on the grid building system, instead of manually instantiating it, let's go into the placed object and we're going to call create and pass in all the data. Okay, so we have this, and this function returns a placed object for the created placed object. And over here on the grid position, instead of the transform, let's refactor our code to receive a placed object instead. So
Sorry, got lost in thought there for a second. I was thinking about making a neat little game, just a map builder, you know. But it won't be a game; it'll more be just like a map editor. But we'll see. uh, where are we at? If build, yeah, he gets rid of that. Instead of instantiating this, he says, go ahead and placed. Huh. You got a whole section in here that he did. Must not have been paying attention to that. What he does is I think he's coming in here and he's got to like re-up this.
The created placed object.
Yeah.
And over here on the grid position, instead of the transform, let's refactor our code to receive a placed object instead. So here, let's replace the transform with a placed object. And logic for this one is always pretty much the same thing. Okay, so I really just
came up here and said placed object. Placed object. Yeah, it's pretty much just going around.
swapped out the transform for a placed object. Then down here, the set placed object, and pass in the placed object. Okay, so now we can finally handle our demolish. Let's do that on the right mouse click.
I'm sorry, what? Didn't I just write that out? Did I write that out somewhere else? Would not surprise me. Yeah. Hold up.
Let's go into the placed object, and we're going to call create and pass in all the data. Okay, so we have this, and this function returns a placed object for the created place.
Okay, that's what I messed up. I wasn't paying attention to that part. Object.
Object. And over here on the grid position, instead of the transform, let's refactor our code to receive a placed object instead. Placed object. So now our demolish. Let's do that on the right mouse click. So you get the grid object on the mouse wheel position. Then we to see if there's something on it. So let's make a function to return the placed object. Okay, now we can to return the placed object. Okay, now we can call this to see where we clicked on. And if this one is not null, then we do have something that we can demolish. So first, for demolishing the visual, let's go into the placed object and let's make a function. Let's call it destroy self to destroy this object. And here we just do a game object and we're going to destroy it. So destroy this game object. Okay, so this will destroy the visual. So now here, go into the placed object and we call destroy self. All right, that won't destroy it. Now we need to cycle through all the grid positions for this object and clear all of them. So for that, this game object. Okay, so this will destroy the visual. So now here, go into the placed object, and we call destroy self. All right, that will destroy it. Now we need to cycle through all the grid positions for this object and clear all of them.
Straighten that up.
So for that, we're going to use pretty much the same logic that we use here. So first we grab the grid position list, and then we go into that one, and we're going to clear it. So we get the grid object, and we're going to clear the grid object, the placed object. All right, except here. Here for the grid position list, instead of grabbing it from the current XZ, we're going to grab it from the XZ on this placed object. So let's actually make a function there to expose this. All right, so that's really... it. Since this placed object already has all of the data it needs, it knows what object it is, where the origin is, and the direction. So using all of this data, we can get all of the grid positions that this object is occupying. So now back on the grid building system, for the grid position list, we just go into this placed object and we ask it to give us the grid position. All right. So
Uh-oh. That didn't look good. I don't know what I did, but everything just like kind of collapsed on me. Bad news bears. Damn. The hell happened? Alright, well, let's keep going. Almost done, folks. Almost done. What happened? That was really weird. I don't know what I hit.
So that's it. Now everything should be working. Let's see. So here I am, and I placed down a normal building, and yep, there you go. Now I right click, and yep, there it is. It did clear it, and it did clear the object. So if I click again, yep, now I can build again. Alright, so that is working. Now let's see for one with an irregular shape. So let's see, place down the gas station, occupying both of these. Now if I right click on this one, yep, it did clear both of them. Now if I click here, place on both of these, now right click on this one, and yep, it did clear both of them. And
I got something going on.
grid position.
I get grid position list. Then I go for each get grid object. Clear it. So it's clearing the object, but not the visual, I guess. Wait, what? I don't know what. All right, let's see. That's not good. What I do? Looks like I'm getting an error with this. Do a little comparison. Trying to keep it on the screen, but it's like wigging out. Sorry. What we got? I'm gonna have to put this over here because it's throwing me off. All right. He's got a whole nother script for this. Yeah, he's got a whole setup script. I guess it's the same thing as doing this, so this just takes those values, puts them in here, and then this says, yeah, this. Little problems everywhere. All right. Sounds like a grid. Shit, place out your yourself. Yeah, I don't know. And now I can't even. I don't know what I just added, but now everything's all. It's let me place multiple on top of each other. So before I introduced that to the system, it was working fine. Ain't that? I did change it to where I got my visual, my prefab in here. All right, let's backtrack a little bit. I know, dogs, I'm coming.
Rotate the visual.
Like I couldn't get that to work.
Object, there's another function to get the rotation angle of a certain direction. That's down here. About the building type. So that means that we need to keep track of what positions each building is occupying. So in order to handle that, let's refactor our script into all of our objects. So we want the data that we need for the object type. Grid building system over here, we are instantiating our builder is responsible to create it, and we pass in all of the data that we need. Alright, so here I made this nice static function. It returns a placed object, and we've got the create, and then for the building type that we want to place. Then we simply do instantiate, the exact same thing that we saw previously. And then we simply do a get component in order to get the placed object component, and we fill in all the data. And finally, we return it. So now this class is responsible for creating the transform and holds all the data related to the building. So now on the grid building system, instead of manually instantiating it, let's go into the placed object and we're going to call create and pass in all the data. Okay, so we have this, and this function returns a placed object. Pass in all the data. Okay, so we have this, and this function returns a placed object for the.
Y. Oh, I'm out of T. Damn.
Created placed object. And over here on the grid position, instead of the transform, let's refactor our code to receive a placed object instead. So here, let's replace the transform with a placed object. And logic for this one is always pretty much the same thing. Okay, so I really just swapped out the transform for a placed object. Then down here, the set placed object and pass in the placed object.
Wait a minute, did I skip step? And I hope I didn't.
Okay, so now we can finally handle our demolish. Let's do that on the right mouse click.
Oh, you know, damn. Because I think he changed this. That's right. Let me see.
Here, the grid position. I can clear this fields that we need. So, for example, this.
Messed up. Like I was like, oh, I'm not gonna do that right now. If you stick to the plan, we'll be He is confused when shit goes wrong.
And then here, just listening to some outfit input.
Just realize how weird that looks. As of right now, why is this off by 1? Yeah, as of right now, I only got like what, 3. So it's fine. Anyways, alright, so right here, trying to cycle through each grid position list, which is here. Grid position list from here. Forgot about that part. Placed object origin. I don't have that. Look into that. Looks like he uses that quite a bit in his.
I used to lie out on the beach, close my eyes, may there be a pretty girl lying on the sand next to
Vector to placed object origin. Get position list. See if that did anything. The problem was I didn't have a list. I wasn't pulling from list to create position list. Position list. Let's see. Index is out of range? What? I am thoroughly confused. Oh, I forgot to. Yeah. Huh. All right, let's try it. Well, it's still busted on that end. Damn. Oh, it actually rotates it. Well, the left and right. Looking at something real quick, trying to figure out what that error means. What line is it giving me the error on? 13? Here? All right, so I'm gonna copy this over and see if it helps it, but I'm noticing he calls the setup this section is called and performs it's a private. Here, I'll just do this. It's a private function setup. Placed object. This is obviously that's vector 2 int origin placed object this dot dir. Having all this up here. This is placed object dot setup. I don't really know how that's going to change it much, but we'll see. Object reference not set to an instance of an object.
Put then the selected one and all. All of them. Then on awake, let's see if I'll do to the first one on the list. Puts in. Okay, let's see. Now play that in. Place down. Everything on the Z be correct. Now if I place here, yep, correct. So factor to int. Then we calculate the rotation offset for. Same thing for the up and right. Y, which is place rotation axis. Set it by rotation, click. Okay, so like this, it should be rotated. On the Z, on 0, and we're in. Let's use this and apply rotated. Now, then we've got the grid position using. All right, left. Yep, left. Let's see. And pass in the current direction. Okay, so now we've got a direction that should, right? Direction. So here, instead of putting in the default one, let's choose the one that we're currently using. Let's see how. how this function is set up. So here on the grid position list, as you can see, the only difference is values. Default like this, we should already be filling in the correct grid positions. Let's see. Alright, so by default we have direction down, so if I click here, it should occupy this one and this one. Click, and yep, it did work, alright. Now I press the R, now I'm looking left. So now if I click here, it should occupy this one and this one. Let's see, click, and yep, it did work. Now I press again, now it's pointing up, so it should place here and here. So click, yep, it did work. Now again for the right, it should place, if I click here, here, and here. So click, and yep, it did work. Alright, so all the grid positions are all correctly being rotated. Now let's actually rotate the visual. Over here on the scriptable object, there's another function to get the rotation angle of a certain direction. So if it sounds rotated by
Well, gotta say, I technically almost got to the end of the video. What I'm gonna do is I'll probably cut out here
by 0
and take my dogs out because they're bugging me. But then I will be back next time. Hopefully I'll have this cleared up and then I'll go over where I actually screwed up. All right, guys. Thanks for tuning in. This is, I think, day 10 of me going over this.